Okay, next is regression discontinuity analysis, and if you can ever use this technique, it is cool. So this is another answer to how do we make a stronger argument for causation or generalization when we don't have random assignment, a common problem when we're actually looking at applied settings. So when we're actually doing practical work in real world settings, we rarely get to use random assignment. So regression discontinuity analysis was specifically designed as a potential tool to actually address that issue and to allow us to make a much stronger causal argument because of a treatment effect when we don't have random assignment. So we're going to talk briefly about what regression discontinuity is, kind of what we're looking for and when we'd use it, what the analytical procedures are in general, and the advantages and disadvantages. And I have a further reading listed here. This can give you some more background on this. So this is more of one of those where I'm trying to give you enough knowledge to know what it is, so you might have some ideas of when you might use it or when it might be the appropriate tool for a problem you might face in a practical setting. The ability to actually understand articles that talk about it, and again, to be a good consumer of research. And this is another one that you may actually be in a situation where I'm hopefully giving you just enough knowledge that you could learn about it if you needed to. My experience with regression discontinuity analysis is, unlike the other two techniques we've talked about so far, not separate entire classes. It was a part of a larger package of applied processes that could be used statistically, probably about the equivalent of a quarter of a semester, so less than a credit hour, to kind of get a general idea of how to run these. So regression discontinuity designs are used when units are assigned a condition based on a cutoff score. So the idea here is we're not using random assignment, but we're also not using some pre-existing factor like classroom 1 or classroom 2 or school 1 or school 2 to determine who gets a treatment or not. What we're actually going to be using generally is going to be a need-based cutoff. So we're basically going to be looking at people that are in need versus those that aren't, and that's who we're going to address with our intervention. So this can often be fairly easy to sell to an organization. So let's see if this intervention actually is going to help, but the way we're going to test it is that we're going to give the intervention to those that are most in need to compare them to the people that are in less need. And that's usually an easier sell. Now, because assignment is not random, statistical estimates may be biased, and that's what happens with most studies, because if we don't have a specific statistical technique to take into account this bias, we have to account for that bias. So for instance, again, if I was having to use a applied method and replacing random assignment, and instead I was using a classroom 1 versus classroom 2 or first years versus second years, there's going to be built-in differences between those groups that I have to somehow account for or just accept that I don't really know if I have causation. Regression discontinuity accounts for this bias when the assignment mechanism is known. So instead of actually measuring or matching groups, I'm actually taking control of an existing known difference to determine who gets put into the various conditions. So the researcher is controlling assignment not through random assignment, but by a pre-known cutoff score. It needs to be a continuous measure, and usually it's going to be a continuous measure that actually is associated with what we're trying to influence. So therefore, it's advantageous over other quasi-experiments because we know the assignment method. We've chosen it, we've taken it, and in fact, we've actually chosen something that is related to what we're interested in. So the cutoff scores are generally going to be based on a mean, though this may change. And again, the reason we would use a mean score is a lot of the times we want to actually split on the mean. In other words, we want to have two equal groups, the group that gets treatment and the group that doesn't. So anyone above the mean would not get the treatment, and anyone below the mean would get the treatment. It does need to be a continuous measure, and it must be measured before any intervention or treatment. Now, we can do regression discontinuity where we actually do not have a predictor or a cutoff score that is directly related to the dependent variable, though this can become a little more tricky. Most of the time, we're actually choosing something that is going to be related to the dependent variable. So for instance, I might be interested in a brand new intervention that I want to test to see if it increases reading scores. So I use pre-existing reading scores that were taken the year before, and the people that are having the most problem reading are the ones that are going to get the treatment, and the ones that are having the least problem reading are not going to get the treatment. So that's an example of how we would set up the regression discontinuity design. So group means cannot be compared cleanly and with confidence if the selection bias is present and we haven't taken control of it. Treatment effects are based on differences in the regression line than the means. So when we look at regression discontinuity, we're not actually looking at the mean difference between the first group and the second group. We're actually looking at how the correlations change between those two groups. So we must account for certain parameters if there's a relationship between the outcome and the assignment variable. So we do need to test for linear relationships, and actually we're wanting linear relationships. We need to make sure that there is not nonlinear relationships, and we also want to make sure that there's no interactions in the data set. If we have a linear relationship without nonlinear and interactions, we have the perfect setup then to run a regression discontinuity. So the idea behind the regression discontinuity is that if there was no treatment effect, so again, we have a cutoff score. The cutoff score here is represented by the green line. And if we had no intervention and we did nothing, we'd expect there to be a significant correlation between our cutoff score and our DV. So the bottom is our cutoff score. That's our pre-measurement. Let's say it's of reading. And then we are actually measuring reading 6 months later. We'd expect if no treatment had been put in place, if everything had stayed relatively the same, everyone's getting the same kind of instruction, the same kind of classes, that there would be a strong correlation between time 1 reading scores and time 2 reading scores. We'd find a continuous regression. We'd find a linear relationship. We would find those solid blue squares would then also be continued into the lower section with those hollow blue squares. That's what we'd expect if there's no effect. But because we did a cutoff on the first variable, the variable along the bottom horizontal axis, to where the people that were doing better at reading are not getting the treatment, and the people that were doing worse at reading are getting the treatment, we're hoping to see a discontinuity. We're expecting to see still two linear relationships, but linear relationships that no longer flow into each other. In other words, if the treatment effect is the difference between where we'd expect to find the lower readers if no intervention had happened and where we actually do find them. So we're expecting to see a discontinuity in our continuous variable, our regression, based on that cutoff score. So this is an example of a very strong argument that regardless of the differences between the two groups, the intervention did work. Because if the intervention didn't work, we wouldn't see the discontinuity. So here's some real-world data. This is a regression discontinuity experiment with no treatment effect. So this is an example of an actual assignment score based on a post-test score. So we have a pre-test, post-test design. We use the pre-test to assign people to control or treatment group, and we expected the treatment group, in this group case, we're actually trying to influence people that are doing well to do even better. What we find is no discontinuity. This would be an example of the treatment has no effect. By contrast, if the treatment had an effect, this is what we would find. We would find that discontinuity. We would find that shift up in the treatment group that was unexpected unless there's a treatment effect. And regardless of how the groups differ, that discontinuity is hard to explain by any other possible confound or explanation other than the treatment must have had an effect. And that's kind of the beauty of when you can use this technique, it is a great technique to look for in applied settings a causal argument of treatment versus no treatment. So the analytic procedures, and again, there's a lot more behind this than I'm going to talk about. We generally do want to center all of the scores, subtract the mean from each score to where basically the mean or the cutoff score is actually 0. We want to examine the relationship visually. We want to plot the data on a scatter plot, and we want to plot that data for both the control group and the treatment group. We do want to make sure that we specify nonlinear trends and interactions and include those parameters in a regression model. So basically, kind of like how we use intra-class correlations, ICC, as a pre-test before potentially doing an ANOVA, we would also use a multiple regression with nonlinear trends and interactions as a pre-test before doing an actual regression discontinuity design. Because the regression discontinuity design, the biggest assumption of that design is that there is a solid linear relationship to begin with, and that if we shift that linear relationship on the actual cutoff point, that's what indicates an effect size. We would then run a regression on the estimated model using a multiple regression procedure, and we'd refine the model, dropping non-significant terms, hopefully finding that the only actual significant predictors are the pretest, the cutoff score, the post-test, the actual DV, and the group variable, a dichotomous variable, treatment or not. The advantages, much more useful than randomized designs when treatment is needed in a real-world setting where randomized designs are not possible, or when need is based on demand. So there's a big solid advantage to using this technique when it is appropriate. Now again, you have to have a pretest, and that pretest has to be continuous. You have to have the post-test, the outcome, it has to be, again, continuous. And you have to be in a situation where you're doing a single treatment versus a non-treatment or comparing two treatments. So you're kind of stuck with a dichotomous design. The disadvantages. Because this is being used in an applied setting, we have to be very careful that we're holding everyone to the right standards. Administrators very well may not adhere to cutoff scores. So for example, if you have a teacher who is supposed to be deciding which kids are going to get the treatment or not, and little Timmy is just slightly above the mean on reading but has really been struggling, and they nudge that person over, that fuzzes that cutoff score. For this to work, the cutoff score has to be 100% protected. Participants may also try to alter their own scores if they know the condition criteria. So again, if this is all happening in one classroom, the kids that are getting the actual interventions may try to share it with others. And also statistics may account for higher order trends and interactions. So again, regression discontinuity is somewhat susceptible to issues with if there is more than just a linear trend involved. So again, it goes down to methodology. You're going to be using this design in an applied setting, and you're probably using it because you're wanting to actually convince administrators that this is a way to get at causation without using a random assignment. But in order for it to work, they have to adhere to the requirements of that cutoff score very vigorously. So again, I hope you get a general idea of when you would use this, how it's used, and what you'd be looking for if you're actually doing this kind of analysis, or if you're reading an article that's using this type of analysis.